right. Good morning, everybody. Today is Friday, May 25th, 2018, and this is Before the First Cup with Jules here on UCY.TV. Happy Friday, everyone. It is a beautiful 71 degrees and sunny here in upstate New York. It's supposed to go up to 85 today. So where do we leave off on Wednesday? We titled the show CDC, Lyme, Mycoplasmas, Deadly New Viruses, and Ebola Investment Bonds. We found out the World Health Organization had set up an investment vehicle to be able to allow investors to invest in curing a pandemic area of a disease to help deliver medicines and probably make profit on them. And after a certain number of individuals dies, and I believe in this Ebola outbreak in the Congo, it was like 250, the bonds and the derivatives would start to pay out to the investors. So it was pretty disturbing. We also looked at Lyme disease, ticks in particular, some sort of co-infection that they're finding, and that would be these mycoplasmas, which are a very primitive form of bacteria. Some crazy new viruses that infect pigs and ticks. There was that PAHPA virus we had talked about that there is no cure for, and I just saw there was some new outbreak in India as well, that a few different cities now have had multiple people die from some sort of brain swelling disease. We talked about potential quarantines. I had mentioned a story that I had done back, I don't know, it was probably I don't even want to say 2012, but maybe 2014, about what rights Americans have during quarantines, and that was because a doctor had come back from Africa from an Ebola zone, and they had decided that she had to go into quarantine in New Jersey. We have organizations such as DARPA that are working on projects to remove viral threats within 60 days. And I want to talk about some history. Now, we've discussed the former WINK Biowarfare program in the United States, and that some of the research came from some not too friendly countries that have been doing experimentation during World War II, and that would be places such as Germany, Russia, and Japan. But here's the story that came out of the National Institute of Health publication by an organization called Health Security from October 1st, 2016, titled, and this got my attention, Open Biowarfare Testing and the Evolution of Values. Well, phew, good thing our values have evolved. I would have to question that anyway, but let's take a look at this. The United States and the United Kingdom ended their outdoor biological warfare testing in populated areas nearly a half a century ago. Yet the conduct, health effects, and propriety of those tests remains controversial. The varied views reflect the limits of currently available test information and the evolving societal values on research involving human subjects. Western political culture has changed since the early days of the American and British testing programs, and people have become less reluctant to question authority. Yes, ding-a-ling. And institutional review boards must now pre-approve research involving human subjects. Well, damn them. Further, the heightened stringency of laboratory containment has accentuated the safety gap between a confined test space and one without physical boundaries, like we found out on Plum Island. And all of this makes less likely that the masses of people would again be unwittingly subject to secret open-air biological warfare tests. So don't worry about us. We're not going to do it anymore, but we were for a while there. The United States and the United Kingdom ended their outdoor biological warfare testing in populated areas, and yet the conduct, the health effects, and propriety of those tests still remain controversial. The varied views reflect the limits of available test information that we have that involved human subjects. experiments with selected agents, i.e., potential biological weapons, are conducted in high containment laboratories, and thus bacteria such as Bacillus anthracis, and that would be anthrax, and Yersinia pestis, and that would be the cause of anthrax and plague, are managed in laboratories with airlock access rooms, reduced inside pressures, and that would prevent the outward airflow as well as filtration of the exhausted air. These requirements began during the later part of the 20th century. Now, doesn't that make you feel all better now? In fact, biological agents deemed dangerous to humans have long received special handling. During World War II, we weren't doing anything crazy. Safety measures for British workers developing anthrax weapons included protective outerwear and meticulous techniques. Quote unquote, structural protection consisted of glass screens near the production machinery to prevent gross splashing, and protection at the American Military Biological Research Facility of Fort Detrick, Maryland, included newly developed laboratory cabinets. Yeah, wow. Investigators would slip their hands into long rubber gloves affixed to portals. Oh, yeah, so I've seen those. And that would enable them to reach the work area. When the agent is released outdoor, like maybe the ticks accidentally or on purpose, containment precautions are literally thrown to the winds, and exposure of the population becomes subject to the erratic air currents and other environmental uncertainties. Yet several countries have engaged in extensive field testing in Japan in the 1930s and 40s, including torturous killing of human subjects, and that would be at Unit 731, as well as in the Soviet Union through the 1980s. The United Kingdom and the United States began conducting open-air experiments during World War II and continued them for decades, often in collaboration with each other and with Canada. And in the late 1950s, the UK had largely ended its offensive biological program, and in 1979, the United States abruptly renounced its own offensive program. Both countries helped establish the 1972 Biological Weapons Convention, and that's a document I can never remember, which aims to universalize the ban on such weaponry. Yeah, well, thank goodness they signed that. However, defensive measures, ding, ding, and this is what I told you about Nixon. That was his little side note when he made the announcement. Defensive measures are permitted, and Dugway Proving Ground in Utah remains a field testing location. Did you hear that, guys? For the United States and its allies. So it's not just our biological weapons. Before the late 1970s, the U.S. and the U.K. conducted numerous open-air tests in other settings as well. And, you know, one of the things that I wanted to mention is that a lot of these killer pathogens aren't really the key things on the plate anymore. We have all kinds of mad science gone mad happening in laboratories where they can flip switches literally in your DNA on and off. They can infect you with stealth viruses, DNA viruses, utilizing things such as phages. I like to call them phages, so if I slip up, please excuse me. But we're going to look at some of that. Let me read just a little bit more here, because this is pretty interesting about the first test sites. British and American researchers during World War II explored the efficacy of dozens of pathogens, and that's that one book I was reading. I don't remember what it's called, The Biology of Doom, I believe. Dozens of pathogens as warfare agents. They included causative agents of anthrax, brucellosis, plague, tularemia, Q fever, and botulism. By the end of the war, the only biological weapons produced in quantity was the UK's arsenal of 5 million anthrax-laced cattle cakes. Ding! Now that's pretty horrifying. I did not know about that before this article. This is also out of the National Institute of Health. 5 million anthrax-laced cattle cakes. The plan was to drop them over Germany's pasture to infect livestock. And I remember reading that the U.S., and maybe this was Carl Grossman actually, who mentioned that we had been working on ways to kill Russian livestock as well, and we didn't want to have to feed all of those people if we had done that. But the UK was working on killing all of Germany's livestock. And although never implemented, the idea was based on field tests on the shores of Pendleclaw, Wales, on Grunyard Island, which was a small landmass off the coast of Scotland. And they did a lot of biological testing there. That Biology of Doom had talked about some of that. After the Grignard testing ended, scientists repeatedly sought to decontaminate the island, but were unsuccessful. The anthrax spore count remained high, and people were forbidden to land there. And in the mid-1980s, scientists found that only 3 of Grignard's 522 acres were heavily contaminated. So massive quantities of seawater and formaldehyde were applied to those adjacent areas. And in 1990, Grignard was deemed safe for humans to return. Kind of like Trump wanting to make Plum Island into a golf course. The Grignard experience confirmed both the lethality and the durability of the anthrax bacilli. So, all right. Actually, maybe we should do one more because I know this affects some listeners. American field testing during the war was limited. The main intended test location was Horn Island off of the Mississippi Gulf Coast, which opened in 1943. 9 months later, after winds were found predominantly blowing toward the mainland, oh no, the island facility was closed, and in January 1945, the biological testing area at Dugway was completed, but the activity there was brief. After the war came to an end, the British and American biological programs were reduced, and Dugway was closed. In 1948, however, a presumed Soviet biological threat prompted the reinvigoration of the American and the British programs. So in 1948, they covertly reactivated everything. All right, so now let's take a step forward. So let's fast forward now 50, 60 years, 48. Oh, well, let's see, 58, 68, 78, 88, 98, 2008, 2018, 70 years to what we have today, tinkering with synthetic biology and synthetic proteins, folding your own proteins, folding DNA into pretty little shapes and smiley faces. And we have people like Bill Gates coming out stating that he believes that the next pandemic could kill 30 million people if the governments don't prepare. We've read this story before, but I'm going to use this to accentuate things. And this is a newer publication, April 28th, 2018. Gates has warned that a new viral disease that could just, mutate because of global warming could kill as many as 30 million people in 6 months if it were to occur in the near future. Oh no, emergency alert. Hold on. Oh, that's a pretty scary sound. Yeah. It's an Amber Alert. The Microsoft entrepreneur believes that such an outbreak is inevitable and that governments across the world are not adequately prepared. We've talked about these labs. I mean, think about some sort of viral vector getting out into the general population that's, was maybe experimental at the time. And it could get out on a shoe or maybe in a researcher that didn't quite take precautions. A lot of these things can live in your eyeballs. I think that was Zika virus they found could live in your eyeballs. According to Business Insider, Gates told a conference hosted by the Massachusetts Medical Society and the New England Journal of Medicine, the government should plan for an outbreak like they do the threat of war. Gates said that he is usually an optimist on issues of health and poverty, noting that the likes of polio and malaria have been successfully combated in some areas of the world. However, he added, there is one area where the world isn't making much progress, and that is pandemic preparedness. New pathogens are emerging all the time and percolating in Africa. And as the world population increases and humanity encroaches on wild environments, we have to get that carbon quotient down to 0. Individuals or small groups could create weaponized viruses able to spread around the globe. Remember, we read about some researchers who had ordered a pox virus, and it made other researchers worried that maybe somebody could build something and accidentally let it out. Gates fears, yes, that a new form of smallpox could be created in the lab and used to wipe out human life. He also added that a fatal new virus may be totally unrecognizable from diseases we've seen in the past. Now, what's interesting about this, I ran across a show that I've seen a few episodes, and I'd highly recommend it if anyone has Amazon Prime or lives up in Canada. I think it's on reruns. But it was a Canadian show called Regenesis. And that's not the book by George Church, though we are going to talk about George Church a little bit later here. It is a TV show out of Canada from one of their Prime movie networks called Regenesis. And if you like the show and some of the topics we talk about here and some of the history of the biowarfare and some of the evil things that are being done down long, dark hallways and butt pats by rich billionaires and government officials, you might like this show. It shows like a day in the life of what it would be like to work at some sort of federally funded, sort of independent lab that reacts to outbreaks, known or unknown, that local health officials don't know how to handle. And they're all scientists, different types of virologists and bioinformatician type people, where they can look at things, they can look at symptoms, they can narrow it down to like DNA sequences and then try to figure out things to kill it. I don't know. It's pretty neat. I mean, I was surprised how much I actually understand now when they're writing things out on the board, but it's called Regenesis. It's on Amazon Prime, and I would highly recommend it because it deals with these exact questions, and they actually did have some sort of smallpox outbreak that was created by someone who had gotten the DNA sequencing for the virus off of the internet. So, all right, how can we stop this? Well, explaining his prediction, Gates showed a simulation by the Institute for Disease Modeling that found that a new flu-like, the one that killed 50 million people in the 1918 pandemic, would likely kill 30 million people within 6 months if it were to break out today. And remember, they'd actually published, I believe, not one but two sequences for the 1918 flu, and scientists were up in arms about that again, stating that they shouldn't be putting this shit on the internet. But then the other researchers were saying, yes, but it's all public knowledge, and we should be able to democratize everything. But, you know, when you can do CRISPR in mommy's back bedroom, it's got to make you worried. In some ways, the world is better prepared in 2018 than in 1918, says Gates, pointing to antiviral drugs and the ability to tackle secondary infections such as pneumonia. However, he argues that globalization and our interconnectedness makes the ease of spreading such a disease more dangerous than ever before. So look out, people. Because another story came out, and this was about a week and a half ago, May 14th, 2018, out of a publication called MedPage Today. Report, the next pandemic will likely be respiratory-based. Our experts argue that increased surveillance on a clinical and public health level is critical. The next pandemic to impact the U.S. will likely be a respiratory spread RNA virus, making preparation at both the clinical and public health levels crucial, argued experts. Instead of relying purely on historical context, these lists of potential pandemics should not be permanently fixed ideas. In the report entitled The Characteristics of a Pandemic Pathogen, the author says that preparedness needs to go beyond the traditional thinking and that some flexibility is required in the approach to combat any future pandemic. Because the next pandemic could be respiratory-based, you should always keep some N95s in your trunk. They're pretty cheap. Contagious during the incubation period when individuals only show mild symptoms, clinicians need to be looking carefully at this particular class of undiagnosed respiratory infection because it is very likely that the next pandemic will come from one of them, says the team. Influenza is the most famous, but there are a whole other lot of viruses where clinicians probably don't even know their names. And they often go undiagnosed, or they go into the wastebasket diagnosis of viral respiratory infections. They're mild infections and not many people test for them, but when you look at that class of virus, they meet many of the criteria for what can cause a pandemic. And because they mutate quickly, I believe. Indeed, the World Health Organization is already shifting their thinking about pandemic pathogens by adding Disease X to the World Health Organization list of priority diseases. Now, where have we seen Disease X before? Well, hold on one second here, because we have DARPA, if the page will load, announcing February 6, 2017, removing the viral threat 2 months to stop Pandemic X from taking hold. Oh. DARPA aims to develop an integrated end-to-end platform that uses nucleic acid sequences to halt the spread of viral infections in 60 days or less. Remember, Bill Gates said that 30 million could die in 60 days from a pandemic, and over the past several years, DARPA has funded research that has pioneered RNA vaccine technology, a medical countermeasure against infectious diseases that use coded genetic constructs to stimulate production of viral proteins in the body, which can trigger a protective antibody response. As a follow-on effort, DARPA-funded research into genetic constructs can directly stimulate production of antibodies in the body. DARPA is now launching the Pandemic Prevention Program, and we've talked about this before. This is the P3, aimed at developing that foundational work into an entire system capable of halting the spread of any viral disease outbreak before it can escalate to pandemic status. Such a capacity would offer a stark contrast to the state of art for developing and deploying traditional vaccines, a process that does not deliver treatments to the patient until months or years or even decades after a viral threat emerges. So this means they want to be prepared before the fact. DARPA's goal is to create a technology platform that can place a protective treatment into health providers' hands within 60 days of a pathogen being identified, and has the treatment-induced protection in patients within 3 days of administration. We need to be able to move at this speed, considering how quickly outbreaks get out of control, and this technology needs to work on any viral disease, whether or not it is one that humans have faced before. Now, I found a story a few days back about some new synthetic biology project that can make virus-resistant supercells. And that got me thinking about the DARPA Pandemic X story. So this is titled, this is at a Singularity Hub, Scientists Kick Off Synthetic Biology Project to Make Virus-Resistant Supercells. Recently, roughly 200 eminent scientists assembled in Boston, which is the pit of lizards for Mad Science Gone Mad. Their agenda, well, would be creating a superhero, human cells impervious to all viral attacks and possibly other killers such as radiation, freezing, aging, or even cancer. The trick isn't a super soldier serum. Instead, the team is relying on tools from synthetic biology to read the cell's genetic blueprint and then to rewrite large chunks of the genome to unlock these superpowers. Now, I mean, come on. Now, is this how they're going to sell it? They're probably going to get Regina Duggan to spin the story to be able to sell this. I mean, this is just crazy. And this is from May 15th, 2018. There is very strong reason to believe that we can produce cells that would be completely resistant to all known viruses, says Jeff Boki, a geneticist at New York University and a co-leader of the project. It should also be possible to engineer other traits, including resistance to prions and to cancer. So, they're going to get everybody to step right up for this. They are going to sell you the longevity, the disease resistance, dangling carrots to get you to be a human guinea pig. And in that Regenesis show, they actually did get around some regulatory issues and tested some of their untested science in humans when some of their friends got sick or ended up in a coma or infected by something they were working on. But it's interesting how they spun the day in the life. And I mean, it really kind of gave me a new look into the world that we dig into every day. So anyway, there's very strong reason to believe that we can produce cells that would be completely resistant to all known viruses. It should also be possible to engineer other traits, including resistance to prions and cancer. And if realized, these ultra-safe cells, good elevator pitch, would have an immediate impact on biotech industry, which often uses cells to manufacture drugs. Dealing with viral contamination is a billion-dollar problem, one that the industry is eager to crack. But the team's main goals isn't a supercell. Rather, they are hoping that the project, dubbed Project ReCode, ding, 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 will help develop a whole suite of molecular tools that enable scientists to write their own code into existing genomes or just fabricate entirely new artificial genomes. Now, who would you think was involved in such a project? Well, they were up in Boston. Well, the idea for making cells resistant to viruses came from, Georgie Porgy Church, yes, who is a prominent synthetic biologist at Harvard University. In an early study using E. coli, which is a common bacterial workhorse in the lab, Church found that he could make the cells resistant to viruses through a process called ReCoding. And this was also when he was looking at E. coli's immune system, and he was tinkering around with CRISPR. It works like this. The cells follow a strict code when translating DNA sequences into amino acids. The building blocks of proteins and DNA's molecular base pairs come in 4 flavors, and that would be CATG. Each 3-letter string of DNA maps to a particular amino acid. For example, AAA is for lysine, or CAG is for glutamine. These 3-letter chunks are called codons, and there are 64 combinations in total. Do we really need to know this? So the process of ReCoding is to pick one codon version for an amino acid, say TCT for serine, and swap out all the redundant variants, which would be like TCC, TCA, TCG, with the new chosen one. You are essentially shrinking the coding table to its bare minimum. But why does this work against viruses? Well, once inside a host, we've talked about how viruses infect an organism. Viruses hijack the cell's protein-making machinery to pump out more copies of themselves. But because they also rely on 64 codons, most of which are now deleted in the recoded cell, and this would be the genetically modified one, the viruses are stuck. Their host no longer has the appropriate machinery to help them make their viral proteins. Previous work from Church's lab found that swapping out 321 codons was sufficient to neutralize the viral invaders while keeping the bacteria healthy. The study follow-up recoded 7 codons in the E. coli gene, which was an effort that required close to 150,000 genetic changes in the organism. Scaling this technique to human cells will be incredibly tough. Recoding every protein in the human genome, for example, would require 400,000 changes in 20,000 human genomes, explained Church. That's why the team is now looking to synthesize a genome from scratch rather than making individual edits with CRISPR or other tools. As Boki colorfully said, it is like you are editing a short story. If you're changing so much of it, you might as well just rewrite the whole damn thing. Oh, God. So what does this mean? It's easier said than done. In gene synthesis, DNA letters are biochemically stitched together one at a time, and although the process results in something similar to natural DNA, it is slow, cumbersome, and expensive. Currently at roughly $1 per 10 DNA letters, synthesizing a 3 billion base pair human genome would rack up a pretty sum. But the team is hopeful that innovations in DNA synthesis technology will help drive the cost down and the existence of the project itself is a good motivator for further developing the technology, they said, expressing confidence that costs will be cut by a factor of 1,000. And, I'm just remembering what we read about this story before, this ReCode project, was in regards to that secret meeting that had happened a few years back. I believe it, again, was in Massachusetts, and it was called by Georgie Porgy Church about creating the synthetic human genome. Or maybe Church was in attendance, and it was called by one of the other lunatics that are working on this stuff, lunatic billionaires. All right, as ambitious as it sounds, Project ReCode is actually a downgrade from an even bolder venture, and yeah, this is what it was called, GP Write. It was first announced in 2016, and GP Write naturally follows the original Human Genome Project, which reads the sequences of 3 billion chemical letters in the DNA blueprint of life. But to synthetic biologists, reading nature's code isn't enough. To fully understand the intricacies hidden within our DNA, they want to be able to program it themselves. So GP Write officially launched with a 2-page document unveiled in the prestigious Journal of Science. Church and 24 other colleagues laid out their goal of synthesizing an entire human genome from scratch, and I think this is part of what his Regenesis book is about. They have that available on Amazon. I haven't read it yet, but I heard that it's pretty good. These artificial genomes could then be inserted into human cells that had their natural DNA removed, potentially allowing, or maybe cut by CRISPR, that was integrated into the human genome via some sort of virus. And we'll take a look at that if we get there today. But it could be inserted into human cells that had their natural DNA removed, potentially allowing scientists to pinpoint sequences that lead to various traits or diseases. Amazing idea? Oh yeah, but unfortunately the team's lofty goals were brought down by a severe lack of funding. Well, phew. Project ReCode, however, presents a revamped, more technically feasible alternative goal, something that's more practical that can attract funding. We thought that it was important to have a community-wide project that people could get behind. Ultra-safe cells are a welcome goal. They could have a major impact on human health, making pharmaceuticals safer, cheaper, and more reliable, says Church. Using a virus-proof cell, biotech companies can deliver vaccines, antibodies, and other drugs without having to worry about viral contamination. No, they're just going to snip, snip, snip you and revamp your coding. Ultra-safe cells may eventually be a good basis for various cell therapies. And ReCoding isn't just limited to making cells impervious to viruses. This same technique can also be used to reduce the risk of cells becoming cancerous. Gene snippets with the letter CG have high mutation rates, which sometimes, combined with other forces, could lead to cancer. So replacing the CGs in codons with synonymous equivalents could, theoretically, cut down on the chances of cells turning cancerous. So far, the scientific community approves this priority shift. To Martin Fressenegger, the synthetic biologist at the Swiss Federal Institute of Technology, he says the move is a terrific idea that is more geared toward utilities and applications of DNA synthesis. That is not to say that GP Write has left its blue sky goals behind. The overall GP Write project is focused on writing, editing, and building large genomes. And if the Project ReCode takes off, the technologies invented could one day allow synthetic biologists to engineer new functions into living organisms or create novel living things from scratch. We see a broad range of applications in areas such as energy, agriculture, healthcare, chemicals, and bioremediation. So step right up. So now, here I find a story this morning, and this was from yesterday, May 24th, 2018, out of a publication called OutbreakNewsToday.com. Press release titled Emergex, and this would be a company, files a patent in the USA for its novel pandemic flu vaccine. Now, good thing, because I bet there's all kinds of funding out there since Billy Gates had come out to warn against one. Emergence Vaccine Holding Limited, which is a biotechnology company pioneering a new approach to enable synthetic vaccine development in the field of infectious diseases, announced today that it has filed a patent in the USA for its novel pandemic flu vaccine. The patent, entitled Reverse Peptide Vaccine, covers the use of peptides derived from human influenza A, which is the most frequent influenza serotype and the cause of the most major flu outbreaks. The first recognized flu pandemic was in 1510, and there have been 15 flu epidemics over the last 500 years. Following the 1918 Spanish flu, and despite the introduction of flu vaccines in the 40s, 4 further flu pandemics have occurred, and flu pandemics have always been preceded by flu outbreaks in animals, which then resulted in the introduction of a viral strain into the human population in which there is no herd immunity from human to human transmission. And there was pandemic characteristics making use of universal flu vaccines based on current circulating flu strains, problematic for the prevention of novel pandemic flu strains entering the human population. So blah, 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 blah. So Emergex synthetic T-cell stimulating influenza vaccines incorporate these human and potentially pandemic-specific targets, and they are currently in preclinical testing. On May 14th, Emergex announced that Innovate UK, which is UK's innovation agency, has awarded the company a grant of £979,318 in their dollars to progress its universal flu vaccine program through preclinical development. In addition to developing its flu vaccine, Emergex is also developing universal flavivirus vaccines, which is cross-reactive against Zika, dengue, and yellow fever, as well as its universal flevovirus vaccine, which is cross-reactive against Ebola and Marburg, which are both hemorrhagic fevers. So, all right, where do we go from here? So we have pandemics coming out of every orifice. I found this, and I thought this was pretty interesting because I didn't really know what the different levels meant, so I thought this might help you in the future. Entering your laboratory, since there are laboratories all over the world working on infectious agents, there are infectious agents that are being shipped to every lab and being carried from a pandemic in some sort of little package to a facility to be tested. So entering your lab, know the biosafety level. Yeah, it's probably some good advice. Starting work in a new laboratory is exciting. You're ready to begin doing awesome science and making new discoveries. However, safety comes first. You need to protect yourself, your colleagues, and the environment from biological organisms and agents that you work with in the lab. Biosafety levels are a way of classifying the precautions you must take and how to practice safe science based upon the agents that you are working with. There are 4 different levels of biosafety as defined by the Center for Disease Control, and the first level starts out with minimal precautions because the minimal risks are biosafety related. Several safety measures increase over the next 3 levels in proportion to the risk. Blah, 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 blah. All right, so biosafety level 1, which is also abbreviated BSL1, this is the everyday struggle to clone your favorite gene into E. coli or to isolate some plasmids, but our biosafety level 1 laboratory has witnessed it all. In a BSL1 lab, you work with well-characterized agents that do not cause any disease or harm in adults that we know about yet, with healthy immune systems. The BSL1 labs have individual doors and at least one sink for washing your hands, but the lab does not need to be isolated within a building. And remember, they said that none of these diseases will cause harm in healthy immune systems, but how about people who are infected with mycoplasmas or other stealth viral infections that cause a hit to their immune system? With mystery diseases, just talking out loud here, but honestly, things that could go out and affect other individuals should still be contained and not accidentally released into the public. The BSL-1 labs, you can work out in the open on your bench using standard microbial practices, but you still should know the risks with the agents that you are working with. Make sure that you receive specific training in the procedure conducted in the lab and have supervision, at least in the beginning of your career. All right, so now biosafety level 2. These are for labs working with agents that pose moderate hazards to lab personnel and the environment. In these labs, you are working with pathogenic or infectious agents that could potentially cause human disease, and that would be like salmonella or influenza. In a BSL-2 lab, you are separate from other labs and you have restricted access. They have self-closing doors with locks as well as sinks for washing near the exit doors, and facilities should contain necessary equipment and supplies to decontaminate laboratory wastes. In a BSL-2 lab, you must also have biosafety cabinets to prevent the spread of infectious aerosols or splashes created during normal procedures or accidents. To work in these labs, you must follow all the safety rules and regulations for a BSL-1 lab, and in addition, you receive specific training on handling pathogenic agents. Always wear protective gear such as lab coats, eye and face protection, and remember to remove your protective clothing before you leave the lab. And if you are working with potential pathogens, you may be required to receive immunizations before you start working, but this may not be the lab for you if you are immunocompromised or immunosuppressed. All right, let's go to the next level. Biosafety level 3 handles agents that can potentially cause lethal disease through inhalation, and this is what Carl Grossman said that Plum Island was a biosafety level 3, which I find kind of frightening because some of the things that they have in that laboratory should be considered biosafety level 4. In these labs, you can work with microorganisms that cause severe human diseases that may be treatable. These labs must be located separately from unrestricted access areas, and they must have special engineering and design features. For example, you enter a BSL laboratory through 2 self-closing doors, and then at least the outer door can be locked in case of a contagion outbreak. And the passage between the 2 doors may contain a clothing changing room, and at least one hands-free automatically operated sink is required to be located near the exit door. If there are different work zones in the same lab, then each zone has to have its own sink, and the lab must have at least one decontamination system and a means to decontaminate all wastes before discarding them. Spaces around the door and ventilation shafts should be sealable for complete decontamination of the area. That sounds pretty scary. And similar to a BSL-2 lab, you also need special training to handle lethal agents. Well, I would hope so. Your institute should collect your blood on a regular basis to test for exposure to agents. And last but not least, biosafety level 4. This is what they are going to put in Manhattan, Kansas, in the new Plum Island that is moving to the Heartland. BSL-4. This would be if you are working with any agents that cause life-threatening diseases with absolutely no available treatments, and also have a high risk of aerosolized transmitted infections, or if you work with an agent that has an unknown risk of transmission, then you work in a BSL-4 laboratory. For example, if you perform research on Ebola and Lassa virus, you would be in a BSL-4 lab. Everybody working in these level 4 labs should be well trained, and your supervisor should be very well experienced in that field. You will find BSL labs in isolated areas away from normally unrestricted accesses of a building. Yeah, so right now it's in the University of Kansas. And this just really scares me. Sometimes they are located in a completely separate building. Well, that I don't know. Labs are of the highest security. They have non-breakable sealed windows. HEPA filters protect their ventilators. They have self-locking doors and facilities with sequential passage containing personal showers and changing rooms. You should be either Class 3. There should be Class 3 biosafety cabinets. And the workers wear pressurized suits. Your institute should provide occupational medical services and offer all possible immunizations, and you should collect serum samples from the staff regularly. So there you have it. And that is in the heartland, a BSL-4. Now let's talk about this, because this is something that has been on the plate for a while, and I see a date, April 16th, 2018, so over a month now. But I want to touch on this because there's research going on all over the world with different safety levels, and I mean, it really wasn't a big distinguishing factor, except one has a cure and one doesn't, but still they can all cause some sort of disease, even in the immunocompromised, so that consists of a lot of different people, because our Western diet and our environments cause immunocomposition, if that's the word. But listen to this. Scientists accidentally, yes, this isn't just accidentally on purpose, this really is, accidentally create mutant enzymes that eat plastic bottles. Now, I heard Hal mention this story, but I want to talk about it on the show, because this happened by accident, which now they're calling a breakthrough. Whoops. How many times do accidents happen in the lab? It's got to make you wonder. The breakthrough, spurred by the discovery of a plastic-eating bug at a Japanese dump, yeah, because it's probably been irradiated, could help solve the global plastic pollution crisis. Now remember, radiation actually causes bacteria and viruses to mutate. Scientists have created a mutant enzyme that breaks down plastic drinking bottles by accident. The breakthrough could help solve the global plastic pollution crisis by enabling for the very first time a full recycling of the bottles. But what happens when they find an accidental enzyme that recycles bodies? I bet they're working on that too. Eat you for lunch. The new research was spurred, and that would be all in the name of keeping things clean after a pandemic. The new research was spurred by the discovery of a 2016 of the first bacterium that is a naturally evolved plastic-eating enzyme at a waste dump in Japan. Scientists have now revealed the detailed structure of the crucial enzyme produced by the bug. The international team then tweaked this enzyme to see how it had evolved, but the test showed that they had inadvertently made the molecule even better at breaking down the PET plastics, which is the plastic used in plastic soft drink bottles. What actually turned out was that we improved the enzyme, which was a bit of a surprise. Whoops. And it is a great, real finding. The mutant enzyme takes a few days to start breaking down the plastic, far faster than the centuries it takes in the oceans. But the researchers are optimistic that this can be speeded up even further, and something out of control isn't going to happen, and it becomes a viable, large-scale process. But remember, we live in an ecosystem, people, so don't let this loose in the environment before you're absolutely certain. What we are hoping to do is use this enzyme to turn plastic back into its original components so we can literally recycle it back into plastic. It means we won't need to dig up any more oil, and fundamentally it should reduce the amount of plastic in the environment. So it's a green process. Of course it is. About 1 million plastic bottles are sold each minute around the globe, and 14% are recycled. Many end up in the oceans, where they have polluted even the most remotest parts, harming the marine life and potentially people who eat the seafood. And it's made a big island the size of Texas or bigger. It is incredibly resistant to degradation. Yeah, but what are these bacteria or enzymes? I want to know, and could these affect living tissue? Some of the images are horrific, and one of these wonder materials has been made a little bit too well. So, however, you are always up against the fact that oil is cheap, so is virgin PET plastic, and it is easy for manufacturers to generate more of the stuff rather than even try to recycle it. But I believe there's a public driver here. Perception is changing, so that many companies are starting to look how it can recycle these. So step right up for your mutant plastic-eating enzyme to launch potentially into the oceans and to help cure an environmental problem. All right. So then, getting back to pandemics, here's a story, May 24th, again yesterday. titled the U.S. Senate HELP Committee, and that the acronym is HELP, Health, Education, Labor, and Pensions Committee, has advanced a bill titled Pandemic and All Hazards Preparedness Act. A Senate committee on Wednesday, and that would be 2 days ago, approved a bill to reauthorize a federal program for health emergencies like large-scale disease outbreaks and major catastrophes. The Health, Education, Labor, and Pension Committee advanced the bill S.2852, and Senator Rand Paul was the only dissenter, and I don't know why, but I'm sure there is a reason. The House has yet to hold a hearing or mark up the companion legislation. And here's a quote from the Homeland Preparedness news site. Senate Help Committee advances Burr's bipartisan bill to reauthorize PAHPA S2852, introduced May 15th by U.S. Senator Richard Burr, a Republican of North Carolina, would reauthorize certain programs under the Pandemic and All Hazards Preparedness Act, more affectionately known as the PAHPA, that are set to expire on September 30th. The law was last reauthorized in 2013 and is on a fast track to the president's desk. The bipartisan S.2852, signed by original co-sponsor Senator Lamar Alexander, Republican of Tennessee, and the U.S. Senator Patty Murray, Democrat of Washington, ranking member of the Senate Help Committee, as well as Bob Casey, Democrat of Pennsylvania, who also serves on the Help Committee. It includes a myriad of provisions aimed at improving the nation's preparedness and response to man-made and naturally occurring threats or chemical, biological, radiological, or nuclear attacks, as well as emerging infectious disease agents, potential pandemics, and antimicrobial resistance. Ding-a-ling-a-ling. So there you have it, people. They are going to fund all of the laboratories who are working on trying to stop Pandemic X from taking hold within 60 days. Now, here's another program that I had read about out of DARPA. This doesn't have a post date on it, but just know that they are working on it. That caught my attention because we had talked about phages in the past, and that would be those viruses that infect bacteria, and they're talking about spraying them on food, which they already are, actually, and using them in all kinds of bacterial treatments to combat antibiotic resistance in these new super bacteria, which is something that the Senate Help Committee bill is looking to combat. This is a program out of DARPA titled Pathogen Predators. Pathogen Predators is a program that focuses on readiness and homeland protection through the development of novel countermeasures against biological threats involving bacterial agents. Now, what works on bacterial agents? Phages typically do by infecting them with some sort of DNA payload that has been engineered or not with something that will kill it. Currently, the most common defense against such a bacterial threat is traditional antibiotics. But while such antibiotics have been remarkably effective in the past, their widespread use has been heightened, and it has heightened the risk of our troops in contracting antibiotic-resistant bacterial infections that are difficult or impossible to treat. So a new type of countermeasure is needed to overcome the threat posed by antibiotic-resistant bacteria. That would be where we are starting our pathogenic predator program, and it aims to develop a dynamic class of therapeutics that use live, motile, predatory bacteria, or maybe a virus, that preys upon other gram-negative bacteria that are pathogenic to humans. Previous in vitro studies have shown that such predators such as Bellidovibrio bacteriovorus and Mycovibrio Agiozenversaris, I don't know, prey upon more than 100 different human pathogens, including several that are multi-drug resistant. These results suggest that it is possible to develop a predator-based therapeutic with efficacy against a broad spectrum of gram-negative pathogens, including those that are resistant to antibiotics. These pathogen predator program speaks to establish the technical feasibility of such an approach for use in humans. Ding, ding, ding. And the program supports fundamental research aimed at developing a molecular level understanding of predator-prey, as well as interactions in studies using in vivo infections. Ding, ding. And there'll be people. In vivo infectious predators are effective, and if pathogens can develop a resistance to a predator over time. I would think so. If you look at the evolution of some sort of super pathogen, they tend, especially if they reproduce quickly, they're pretty smart when they reproduce, and they tend to breed out vulnerabilities. If successful, pathogenic predators will lay the groundwork for a living predator-based therapeutic that is safe and efficacious against a large number of infectious diseases, including those that are resistant to conventional treatments. Further advances in this area may also be applied to a wide range of biological technologies, including the autonomous control of epidemics. So look out, people. They are looking to get this into people. So now we covered a story the other day when we were looking at bacteriophages. The FDA approves the use of bacteriophages to be added to meat and poultry products, and this would be from 2006, it appears. Let me see if I can zoom in here. Control++. The FDA approves the use of bacteriophages to be added to meat and poultry products. August 18, 2006, the U.S. Food and Drug Administration announced that it had approved the use of bacteriophage preparations made from 6 individually purified phages to be used in meat and poultry products as an antimicrobial agent. All right, guys, have an awesome weekend. I'll catch up with you next week.